Hey everyone, welcome back to the channel Code with AKJ. Today is day 25 of solving LeetCode 75 challenge, and today we are going to solve an exciting problem, that is asteroid collision. So we'll start with our brute force approach and then optimize it using stacks for better performance. But before we begin, if you find my videos helpful, make sure to like, share and subscribe it. It really motivates me to keep bringing more such coding content. So let's get started with our problem statement. We are given an array asteroids of integers representing asteroids in a row. The indices of the asteroid in the array represent their relative position in space. So for each asteroid, the absolute value represents its size and the sign represents its direction. That is positive meaning right, negative meaning left. Each asteroid moves at the same speed. Find out the state of the asteroids after all collisions. So if two asteroids meet, the smaller one will explode. If both are the same size, both will explode. Two asteroids moving in the same direction will never meet. So given problem statement here, we have an array of integers where the absolute value represents the asteroid size. That is, here 5 is the size of this given asteroid, 10 is the size of this given asteroid. Coming to this asteroid, the absolute value of -y is 5, so the size of this particular asteroid would be 5. The sign represents the direction, that is positive means right and negative means left. So this particular asteroid moves in right direction, this particular asteroid moves in right direction, and this particular asteroid moves in left direction. The speed of all these asteroids would be same, so the smaller asteroid explodes, or if they are equal, both disappear. So given conditions here are that the smaller asteroid would explode if they meet the bigger one. For example, the asteroid of size 3 would explode if it meet with the asteroid which is greater than or equal to the size of the second asteroid, that is greater than or equal to 3. So here in this case, the asteroid of size 10 and the asteroid of size 5, the 10 asteroid moves in right direction, the 5 asteroid moves in left direction, so they would collide. So if they collide, the asteroid 5 would explode because 5 is less than 10. And the asteroids of same size, when it comes to the same size, they both would explode. So this was the problem statement. So let's see a few more examples given here. So example 1 is that the 10 and -5 would collide, resulting in 10, and the 5 and 10 would never collide as it moves in the same direction, that is the right direction. Coming to the second example, the asteroids 8 and -8 would collide, exploding each other. So the final array would represent an empty array, that is no asteroids are present in this given array. And coming to the final example, here 2 and -5 would collide and resulting in -5, that is 2 would disappear from this asteroid array. And finally 10 and -5 would collide, resulting in 10, that is -5 would explode and disappear from the array. So finally the one and only asteroid would remain in our asteroids array, that would be 10. So we'll return 10 as an answer. So let's get started with our brute force approach. So in our approach, we'll use two nested loops. We'll check each and every asteroid with the next one, and we'll check the collisions. So if the collision happen, we'll restart the check from the beginning. For example, we'll use two for loops. We'll also take a variable change, that is it will occur a collision or not. So initially it will be true, and we'll check each and every asteroid with the next asteroid whether it would collide or not. We'll also take a vector of temp or answer to store the resultant asteroid after collision. Before inserting the asteroids into our temp vector, we'll initially check whether temp vector is empty or not. So if it is empty, we'll directly insert our asteroid value into our temp vector, and if not, we'll check the latest value, that is the temp back value, whether it is positive or negative based on its sign. So if the temp back is greater than 0 and asteroid's value is less than 0, now we have two conditions. So based on these two conditions, we can say that they will collide and whether which asteroid would explode first. So based on this, we have two conditions. One would be to check the absolute values of both the asteroid values, that is absolute value of temp back value and absolute value of the current asteroid value. And if the temp back value is less than the current asteroid value, then we'll pop the temp value, since the size of this temp back value is less than the current asteroid value. And finally, we'll push our current asteroid value into our temp vector value from false to true. And if the size of the both value, that is the size of the temp back value and the current asteroid values are same, then we'll explode the both asteroids and we'll change our variable from false to true as well. So in these both cases, we'll change our value from false to true, and based on the size, we'll try to pop the temp value. So these would be the conditions where we need to ensure which particular asteroid would collide based on its absolute value and size. So this would be our brute force approach. So the time complexity of this approach would be O of n square to compare each and every asteroid multiple times. And here the time complexity would be O of n, as we are storing the values in our new array, that is temp array. So let's move on to our code and let's submit. So here's the brute force approach code where we'll take the variable bool that is changed, which would be initially true, and we'll take a loop until or unless this change value becomes false. So initially for every loop, the changed variable would be false, that is no collision happened initially. We'll also take a vector of int of temp to store all the resultant collision values. That is, if two asteroids collide, the resultant asteroid would be inside this particular temp vector. And we'll check for each and every asteroid by iterating over our asteroids array. So here we'll check the two conditions, that is if the temp vector is initially empty or not. So if it is empty, we'll directly push our asteroid value into our temp vector, and if not, if there already a value exists in a temp vector, we'll check whether the temp vector is empty or not, and also we'll check if the temp back values, that is the recent value in our temp vector, is a positive value and the current asteroid value is negative value. This particular condition makes sure that the two asteroids are coming in opposite direction and they are going to collide. So now since these asteroids are going to collide, we have two conditions here, that which of the two asteroids would collide, and if not, if the size of both are same or not. So to compare the size of both the asteroids, we'll check the absolute value of both the asteroids, that is absolute value of temp back, and absolute value of current asteroid value, that is asteroids of I. If the size of the temp back value is less than the current asteroid value, the asteroid with smaller size would collide and disappear. That means we need to pop the temp value, that is temp dot pop back, and we'll push the greatest asteroid value, that is asteroids of I, into our temp vector, and we'll change our bool variable from false to true. That means the collision happened. There would be one more condition where the size of both the asteroids would be same, that is the absolute value of temp back and the absolute value of current asteroid value is same. So if they both are same, we will not consider any of the value into our temp vector. So we'll remove the temp back value, that is temp dot pop back, and we'll also not insert the current asteroid value into our temp vector, and we also change the collision from false to true. So in this way we have handled both the conditions, that is if the size of both the asteroids are different and if the size of both the asteroids are same. So after finishing this particular for loop, we'll update our asteroids vector with our temp vector, and finally we'll return our asteroids vector. So let's quickly run this code. It's getting accepted, so let's submit. As you can see, it gives us successful submission. So clearly this approach is inefficient as we are using two for loops and an external space here temp. So let's quickly optimize it. So in our optimal approach, we can use a stack to handle collisions more efficiently. So the idea here is to push the asteroids into our stack. So if the asteroid is moving right, that is in positive direction, we'll push it into our stack. So if an asteroid is moving left, collides with the topmost stack value, that is topmost asteroid. So in that condition, we have three cases. So the smaller one explodes, and if equal, they both will explode, and if the left asteroid survives, we'll keep checking with the collisions. So this would be our idea in our optimal approach. So instead of using a vector of temp and store the collisions and using a while loop to check for each and every collision and comparing two asteroids, we'll use a stack where we'll store the asteroids which are moving in right direction into our stack, and whenever we encounter a left moving asteroid, we'll compare it with our topmost element of our stack and we'll collide the both asteroids and we'll check based on its size whether which particular asteroid would explode. Based on that, we'll remove the topmost stack element or we'll neglect our current asteroid. So this would be our optimal approach. So the time complexity of this approach would be O of n, as each asteroid is pushed or popped at most once, and the space complexity of this approach would be O of n as well. So let's quickly move on to our code and let's do a quick dry run on all the three examples present in our problem statement. So here's the code for our optimal approach where we are going to use a stack to handle the collisions effectively. So we will take the size of our asteroid vector. We'll also take a stack of int and we'll also take an answer vector here. So we'll iterate over our asteroids vector. Again, we'll check whether the stack is empty or not and the current asteroid value is negative and the recent stack top value is positive. So based on this condition, we'll try to check whether which particular asteroid would collide and disappear. So for that, we'll calculate the difference of it based on their signs, that is the asteroids of I plus stack dot top value. So based on this particular difference, we can identify which asteroid would get disappeared, which would explode. So if the difference value is greater than 0, it means the stack dot top value is greater than asteroids of I, that is the current asteroid. So we'll nullify the current asteroid value, that is asteroids of I becomes 0. And if in case the difference value becomes less than 0, it means the stack dot top value, that is the previous asteroid value size, is less than the current asteroid value. So we'll pop our stack dot top value, that is using s dot pop function. So if the difference value is equals to 0, we'll make both the asteroids collide, that is we'll make both the asteroids explode, that is asteroids of I becomes 0, and we'll also remove the stack dot top value using stack dot pop function. So in this way, we'll handle the collisions using stack. And finally, we'll check if the asteroids of I, that is the current asteroid value, is not equals to 0, then only we are gonna push this particular value into our stack. So after finishing our for loop, our stack contains all the asteroids which collided but never exploded. So we'll use a while loop to store all those values into our answer vector. And since stack follows last in first out method, we'll reverse our answer vector and we'll finally return our answer vector. So let's quickly run this code. It's getting accepted, so let's submit. As you can see, this approach also gives a successful submission. So the stack approach is much more efficient than our brute force approach as it processes each asteroids in just one pass. So let's quickly dry run this particular approach with our three examples, example 1, 2 and 3. So let's do a quick dry run on these three examples. So since we are using stack, so initially the stack would be empty. So based on the signs, we'll try to push the asteroids which are moving to the right direction into our stack. And whenever we encounter a negative sign asteroid, we'll try to compare it with our stack tops value. So here, let's start iterating from index starting with 0. So since here the stack is empty, we push this asteroid value into our stack. So when we move on to this particular index, so we'll again check whether the stack is empty or not. So here, since it is not empty, it is also not a negative signed asteroid, we'll also push this asteroid into our stack. So when we finally move to our final index and final asteroid value, so here the stack is not empty as well as the current asteroid value is less than 0 and the top value of our stack is greater than 0. Here we can confirm that these two asteroids are going to collide. To check which particular asteroid is going to explode, we'll check the conditions. So before trying to find the condition, we'll calculate the diff value. So here the diff value would be 10 minus 5, that is 5. So here, since the difference value here is greater than 0, which means the current asteroid value size is less than the stack's top value. So in this case, we are going to nullify our current asteroid value, that is this current asteroid value becomes 0, which is it is going to be exploded. So minus 5 gets deleted from our asteroids vector. So after finishing our iteration of this given asteroid vector, we'll check the values in our stack and we'll store these values into our answer vector. So in our answer vector, while iterating over our stack, the value becomes 10 and 5. And after reversing this vector, we'll get the values as 5 and 10. So in our first example, the answer would be 5 and 10. So let's quickly dry run with our second example here. So initially the stack would be empty and we'll insert the asteroid with the positive sign. So the first value is 8, that is the positive 8. So we'll insert this particular asteroid into our stack of size 8. And when we move to the final asteroid, since we encountered a negative 8 and the stack top value is positive 8, and since they both are moving in opposite directions, so it is going to collide. So we'll calculate the difference value here, that is 8 plus minus 8, which becomes 0. So in this particular case where difference becomes 0, both the asteroids would collide and explode. So we'll remove the topmost stack value, that is we'll remove 8 from this stack, and we'll also make our asteroid of I to 0. So after performing this collision, our stack contains empty value and we'll store this value into our answer vector, and after reversing it we'll get an empty vector. So in our example 2, our answer would be an empty vector. So finally in our third example, we'll also take a stack which will be initially empty. We'll store all the positive sign asteroids into it. So initially 10 would go inside our stack. Finally the 2 pushes into our stack, and when we reach out to the final asteroid which is having minus as a sign, since the stack top value is greater than 0 and the current asteroid value is less than 0, so these two asteroids gonna collide here. So before to check which particular asteroid would explode, we'll calculate the difference value, that is 2 minus 5, that is minus 3. So here, since the difference value is less than 0, which means the asteroid's top value size is less than the current asteroid value. So in this case, we'll remove the stack top value. So after performing the collision, our stack contains 10. After collision, since the smaller asteroid would explode, we'll insert our larger asteroid into our stack. So 5 gets inserted into our stack. So the stack contains 5 and 10. So we'll insert the values into our answer vector, that is 5 and 10. So after reversing this answer vector, we'll get our answer as 10 and 5. So in our third example, the answer would be 10 and 5. So this was a quick dry run on 3 examples, example 1, 2 and 3, based on our stack based approach. So let's quickly analyze the time complexity and space complexity of all the approaches we have discussed here. So in our brute force approach, the time complexity was O of n square, as we have used 2 while loops to check each and every asteroid's collision, and space complexity was O of n, as we have used an external data structure temp to store the collided asteroids. And in our optimal approach, where we have used stack based approach, the time complexity was O of n, as each asteroid is pushed or popped at once, and complexity was O of n, as we have used stack to store all the asteroids. So clearly the stack approach is much more efficient than our brute force approach, as it processes each asteroid in just one pass. And that's it for today's video. Hope you find this explanation helpful. So if you did, don't forget to like, share and subscribe to the channel. Also drop a comment below with your approach or any questions you have. I would love to hear from you. So I'll see you in the next video. Until then, keep coding and keep growing. Thank you.